Hey, welcome back. This is test 5 review for Cup 2. And let's take a look. So I'm going to be covering chapter 10, sections 10.1, 10.2, 10.3, 10.4, 10.5. We'll begin with 10.1, obviously. And in section 10.1, I'll look at problems like 11 to 15 odd. These are all odd sets, but sometimes I do have to take the even problems if I've done like every single problem that's reasonable in my videos or in homework. So just be aware. Anyways, 37 to 39, and then 51 to 55. And basically, the types of problems are just sketch the parabola, sketch the ellipse, sketch the hyperbola. You may have to complete the square. You have to identify foci, vertices, center, that sort of stuff. Okay, so we'll begin with the parabola. So basically you have to sketch the parabola and all of its detail. Sketch parabola. And that'll include the vertex and the focus and the directrix. And of course also ID that information as well. So ID the vertex, the directrix, and the focus. Okay, so number 13, we have given y squared minus 4y minus 4x equals 0, and the y is squared, so you know it's going to be like a sideways facing parabola. The standard form, it's either going to be y minus k squared equals 4p times x minus h, or with the x minus h and the y minus k reversed. Okay, so those components can be kind of reversed. Okay, so to get it in that form, to identify the vertex, I need to to get all the y stuff on one side, push all the x stuff to the other. Okay, so I have y squared minus 4y. On the other side, I got 4x. Then I got to complete the square on that left side. Okay, so I'll have y squared minus 4y plus blank. And on the other side, I have 4x plus blank. So I'll put in negative 4 over 2, square it, and that'll be the thing that I use to complete the square. So negative 2 squared is 4, so I add 4 in on both sides. Okay. And then on the left, just go ahead and factor it. On the right, factor that as well, so you have a leading coefficient of 1 on the x. And now we're in the appropriate form. So the vertex you can read off of this formula. It'll just be at negative 1, 2. Then we know it's a sideways facing parabola, and also the p-value. I guess we got to get that. So to get the p-value, you just set 4p equal to 4. Okay, whatever's in front of that x minus h part is what you use. So here we have 4p equal to 4, so p is going to be 1. So we have a positive p-value, the y is squared, so the orientation will be something like that, okay? Sideways facing to the right. So in that case, we need to go forward, but we need to manipulate the x-coordinate of the vertex to get to the focus. Okay, so it would be negative 1, and we have to move by 1, okay, and then comma 2. So 0, 2 is the focus if you wish to rewrite that. It's okay to leave it like that though. And then the directrix, in this orientation we need a formula x equals something. In particular, it'll be moving in the x direction again by 1. And so for the formula for the directrix will be the x-coordinate of the vertex, which is negative 1, and then you have to move left in order to get there by 1, okay, by the p-value. So the directrix will end up being x equals negative 2. Okay, and then we just go ahead and graph all this business. And let's see, the vertex is negative 1, 1, 2. And then the focus, I need to move over 1 to the right. There it is. And the directrix will be right here. And then you could kind of just guesstimate the shape of the parabola, whether it's, how kind of flat it is. You can guess at that. Okay, so there's the answer with all of its bells and whistles. So you need the vertex, the focus, and the directrix, and you need to label all that. You need to identify all that, and then you need to go over here and graph it all. Okay. Okay, so that's the parabola. Let's look at the next guy, the ellipse. Okay. So in this case, we want you to sketch the ellipse, and that includes the foci, the vertices, the minor vertices in the center. And of course, ID all of that stuff. So ID the foci, the center, and all the vertices. You can just do the vertices associated with the A value. If you want for completion, do the B values, but you'll have to graph those anyway. So it's kind of like you kind of have to get those all 4 vertices. Anyways, let's take a look at this example. I accidentally sort of borrowed my. I'll probably have to end up taking, because there aren't that many of these problems in the book. I'll probably end up going back to like a pre-calculus book and just finding some. Because these are really just pre-calculus problems. Okay. Anyways, for this guy, we want to kind of collect all the x stuff together and then get a leading coefficient of 1 on the x squared. So I'm going to go 9, factor out the 9. I'm going to have x squared minus 4x, and then plus, I got to complete the square on that, and then plus the y stuff. I already have a leading coefficient of 1 there, so y squared plus 6y, and then I'll have to complete the square. Push the 18 to the other side to get negative 18 plus blank plus blank. Complete the square on the first one, it's negative 4 over 2 squared. So negative 2 squared is 4, so add 4. You can't just add 4 to the other side though, right? Because it's really technically 36. You have actually added in 36 when you add in the 4, because that 9 has to multiply by the 4. Okay, so the other guy is 6 over 2 squared. That'll be 9. Okay, and I add that in on the other side. Crud. So I see I made a mistake in my notes. So let me cheat a little and make this 18. Instead of 18, let's make it negative 9. Or no, I want to make it, what do I want to make it? So what do I have right now? 36 plus 9 is 45. I want to get a 9. So I'm going to subtract away 36. Okay, so minus, we'll just pretend that this 18 was a 36. Okay, right here. Okay, so hopefully that wasn't too traumatizing for you. I wrote it down wrong, and then I edited it in my notes, and I edited it incorrectly, so sorry about that. Okay, so anyways, everything else should be fine now. We can go ahead and factor on the left. We get x minus 2 squared, and then y plus 3 squared. And then on the right, these cancel, and you're just left with a 9. Okay. So divide everything by 9. You get x minus 2 squared plus y plus 3 squared over 9. So this is technically over 1 if you wish. And then on the other side you have that 1 sitting there. So we need the a, b, and c values, and then the foci and all that stuff. So a is the bigger number in the denominator. 9 is a squared, so a is 3. B is just 1. And then c we can find by taking the square root of a squared minus b squared, which is root 8. And in order to graph that, I get a decimal, so about 2.8. Okay, I don't need the eccentricity. All that stuff's great, but for the test, I don't need it. The vertex will be at 2, negative 3. And then you might want to start getting a sort of a picture of what you're dealing with, so you don't screw up moving around to get to your foci and vertices. So 1, 2, and that looks like we're going down 3. 1, 2, 3. Okay. The bigger number is with the y, so you're going to be going up and down to get to the main vertices, or the major vertices, I guess call them. So I'm going up and down by 3. Whoops, this should be the center. The 2, negative 3 is the center, not the vertex. So this is the center. And then to get to the vertices, you're manipulating the y coordinate. You're going up and down by 3. So if I go up 1, 2, 3, I'm right on the x-axis. Go down 3, 1, 2, 3, and I'm right here. And then the foci, I have to, again, manipulate the y-coordinate of the vertex, so -3 plus or minus √8. And you can just leave your answer like that, as long as you're graphing it over here. So it's about 2.8 right here and right here. And then finally, the minor vertices, which I just say VM. I have to manipulate the x-coordinate of the center, so 2 plus or minus 1, comma, -3. Okay, so plus or minus 1 will push me over there, and then push me over here, and then you connect your dots. Make sure the foci are inside the ellipse. Okay, and there's the picture. Okay, so I should see 1, 2, 3, 4, 5, 6, 7 little dots, and then the ellipse flying around there. Okay, let's move on to the hyperbola. So sketch then the hyperbola. And I would expect to see kind of that boxed thing. Also the asymptotes. You don't need the formulas for the asymptotes, you just need to draw them through the corners of the box. Then we need the vertices, obviously the branches, and the foci. And I'll remind you on the test everything you need. And then, okay, so let's look at this. Actually, I got this one from the book, number 40, y squared minus 16 x squared plus 64 x minus 208 equals 0. So again, I need to kind of isolate the y material. So I don't have anything else to isolate, just the y squared. And then the x stuff, I need a leading coefficient of 1 on the x squared to complete the square. So I'll have x squared, then minus 4x, and then plus something. And then on the other side, I'm going to move the 208, right? So I have 208 over here, and then completing the square, I'm going to have to add in something. So what do I add in? We got -4 over 2, and then square that. So I have -2 squared, which is 4. And then on the other side, you're not adding in just 4, it's the -16 times the 4. So you'll have a -64 over here. Factor stuff, so y squared minus 16 times x minus 2 squared equals, that'll be 144 when all is said and done. Then you need 1 on the right-hand side, so you'll divide everything by 144. 16 over 144 is the same as 1 over 9. So I have a 9 in the denominator there. Okay, then we need our A, B, and C values. So this time the A is just with whatever's positive. So it's with the y term here, the y squared term here. And that'll be square root of 144, which is 12. That makes the B value 3. And then the C value, that formula is A squared plus B squared. So that's 144 plus 9, which is just square root of 153, I think. And then let's get an approximation so we can graph it, 12.37-ish. Right, so the center here then is 2, 0. Then the orientation, because the y portion is positive, we know we're going to be kind of oriented up and down, like something like this. So I'm moving up and down to get to the vertices and the foci. In other words, manipulating the y coordinate. So up and down by 12. And then for the foci, I'll be going up and down by root 153. And you could leave your answers in that format. Then for the minor kind of vertices, they're not really vertices at all at this point. They're just kind of points on a box. It'll be manipulating the x-coordinate by 3. So 2 plus or minus 3, comma, then 0. Okay, once you get all your material together, go ahead and plot the thing. So I'm centered at 2, 0. On the y-axis, I'm going to go by 2's just because I got to go up to 12. So 2, 4, 6, 8, 10, 12, 14, and likewise downwards in the negative direction. -2, -4, 6, 8, 10, -12, -14-ish. All right, so that should be good. I think I have to go over left and right by 3. Let's just put a couple more in there. 1, 2, 3. 4. Right, so 2, 0, and then we're going up and down by 12 to get to the main vertices. Oops, I went by 13 there, or 14, I'm really carried away. So up 12, down 12. To get to the foci, it's not much more, right? It's just a little bit above 12 and negative 12 at 12.37. Left and right by 3. 1, 2, 3 here, and then 1, 2, 3 here. And then make your box. The foci should be on the outside of the box. So the foci are on the outside of the vertices as opposed to for the ellipse. Get your asymptotes. So I should see some asymptotes. That guides your branches. And then finally get your branches on there, and then you should be done. Okay, so hopefully that's clear. So mainly these problems, the techniques you have to learn are complete the square, and yeah, I think that's the hard part. It's just really, do you know how to complete the square? Okay, I hope we can do that. All right, so 10.2 then we start getting into the parametric equations. So just being able to graph them using the point plotting method or doing some sort of eliminating the parameter type deal. So 10.2, I'm looking at problems like 1 to 19 odd, and then 23 to 31, and then problems like 39 to 49. Okay, so we had some graphing stuff, and then we also had, yeah, mainly just graphing. I'm looking at my examples. So the first one, x equals t minus 3, and then y equals t all over t minus 3. I'm going to eliminate the parameter and try to graph it. And then you have to talk about orientation as well. So you got to put little arrows telling you which direction of travel you're dealing with. So first I'll eliminate the parameter t. So solving for t in the first equation gives me x plus 3. And then you substitute that expression into the other equation. So you get y equals x plus 3 all over x plus 3 minus 3, which will be x plus 3 all over x. You could simplify that. Y equals, just butterflying it, x over x, which is 1, plus 3 over x. What is this guy? This is a shifted up version of your basic rational function. So remember, your rational looks like this. This thing just shifts up the horizontal asymptote 1. So the picture you'll end with is there's an asymptote here at 1. There's also an asymptote at 0, which you can't see because it's right on the y-axis. And then your picture should look something like this. Okay. And you could look for the x-intercept will be at -3. So 1, 2, 3. Let's just kind of at least get that bit of information in there. Okay, so that's like, 80% of the problem. The other 20% is getting the orientation. For that, you really need to do a table and then kind of just look at the movement on the graph. So I'll start with something kind of negative. So putting -1 in for t, x will be -4, and then y will be -1 over -4, which will be 1/4. Okay, so -4, 1/4 is about right here. So that's that t is -1. And then try 0, keep it easy, -3. And then the other guy is just 0. That was the intercept. So it's right here at t equals 0. In other words, the orientation on this branch is going down. Then hopefully skip to a t value on the other side where the x values are positive. So you need the t value to be greater than 3. So I'll take t as, we'll try 4. Okay, so 4 minus 3 is 1. And then 4 all over 4 minus 3 is just 4 over 1. So just give me 4. So at 1, I should be at 4 up here somewhere. So that's t equals 4. And then let's try something like 5. So 5 minus 3 is 2. And then plug in 2 all over 2 minus 1, 2. well, I mean t is 5, so 5 over 5 minus 3 is 5/2, which is about 2.5, right? So at 2, we're lower, and that would be t equals 5. So again, we're going downwards on the branch. So you must indicate your orientation. That's one of the awesome things about working with parametric equations, is that we have orientation on the curve. Okay. Another thing that's really important is your ability to create the equation of a line given 2 points. That will come up again in Calc 3. So just for example, I picked 43, but I don't think it's a very good example. But we want the equation, a parametric equation of a line that passes through, in this case, the points 0, 0, and 4, -7. So the formula is always x equals x2 minus x1 t. I think in the video I use 0, x sub 0, and x sub 1. So let me do that. So x sub 1 and x sub 0. Where this guy is x sub 0 and this guy is x sub 1. And this will be y sub 0 and this will be y sub 1. Okay. So it's x1 minus x sub 0 plus x sub 0. So in this case, x equals 4 minus 0t plus 0. It'll just be 4t at the end of the day. And then y would equal, always equals x1 minus x sub, or sorry, y's, right? Y1 minus y sub 0 times t plus y sub 0. Y would then equal -7 minus 0 times t plus y sub 0, which is 0. And then y would equal -7t. Okay, so those would be your parametric equations. Okay, so that's definitely important. I'm 100% positively sure we'll put one of those on the test. Okay, right. Anyways, let's move on to 10.3, where we start connecting parametric equations to calculus, in particular, probably some derivative problems. I'll be sort of selecting questions from the set 9 to 21, and then 33 to 41, and then 49 to 53-ish. Let's take a look here. So first, definitely derivatives. Can you take a derivative of a parametric equation? So let's say we have x is 4 cosine theta, and then y is 4 sine theta. And then we want to evaluate the first and second derivative at pi over 4. The book wants you to note the concavity of this implied by the second derivative. So let's take a look. Remember, the dy over dx is pretty simple. You can just take the derivative of y with respect to theta, which will end up being 4 cosine theta, and then put that all over the derivative of x with respect to theta. So that would be -4 sine theta. Simplifying, you'll get negative cotan theta. And then we need to evaluate it at pi over 4. Okay. Theta equals pi over 4. And I'll just kind of write it like that so I don't have to repeat it every time. Right, so the cotan of pi over 4 is 1, and then with a negative in front of it, it's -1. So the graph would have a negative slope at this point. Okay, the tangent line to the graph here would have a negative slope. As negative slope. You could just put the -1. I'm doing this for completion because I believe the book asked for they asked for what's the implication of this -1, and ultimately, you know, it's just basically Calc 1 stuff. Let's look at the second derivative. So the derivative, whoops, I'm gonna put the little, I always forget where to put the little 2, goes inside here, all over dx2. So this one is the weird one, right? You can't just then take the second derivative of y with respect to theta and put it over the second derivative of x with respect to theta. No. The first thing you need to do is kind of take the derivative of the derivative with respect to theta, and you plop that in the top here. So the derivative of cotan is negative cosecant squared. So negative cosecant squared is cosecant squared theta. And then in the denominator, you're putting the derivative of x with respect to theta, which we found right here. Okay, so you just kind of copy and paste that right here. 1 over sine theta is just another factor of cosecant. So what you're ending up with is negative 1/4 cosecant cubed theta. And then we want to evaluate this character at pi over 4. If I can get my mouse to work. There it goes. So again, pi over 4. So you get negative 1/4. Cosecant of pi over 4 is radical 2. So just from trig. And so what we'll get is radical 2 cubed. Radical 2 cubed is 2 root 2. So you end up with negative root 2 over 2, believe it or not. And that would imply the curve, whatever the heck it is concave down in an interval around this point. Okay, so concave down. Okay. Let's move on to 10.4. So 10.4, we've introduced the polar equations now. And in particular, I'll be looking at the following set of type problems. 10.4, 25 to 47 odd, and then 81 to 85 odd. And I want you to be able to convert rectangular to polar equations in particular. So I know you can do the points, that's pretty easy, but I need you to be able to convert rectangular equations to polar equations. I need you to be able to graph the polar equations and that sort of thing. Okay, so first let's just do some converting. So 37, r equals 3 secant theta. So basically you're moving back and forth from something like r equals f of theta, so something with r equals something in terms of theta, over to y equals f of x, right? So something with y on the left, hopefully, and then some expression in terms of x on the right. Sometimes you have to leave it implicit, okay? So just be aware. But ultimately, in this problem, we are going from left to right. So we want to end up with something kind of familiar to us in the rectangular coordinate system. So you have to know all your conversion formulas. So you can almost regenerate them if you just know this kind of picture where you have this scenario going on. This is your kind of x, this is your y, and it's this, and this is r comma theta, with r here and theta here. And then you could always say, well, cosine of theta is the same as adjacent over hypotenuse, so r is, or rather x is r cosine theta, and then sine of theta is equal to y all over r, so y would equal r sine theta, and then of course tan of theta would equal opposite over adjacent, and then r squared is x squared plus y squared. And if you can kind of unpack those equations from that little picture, you'll be in good stead with the calculus gods. Okay. All right. So let's go ahead and play around with this guy. You may need a little bit of creativity. So these questions aren't always, literally programmable like a computer could figure it out. You need to use your brain. Okay. All right, so let's rewrite it. R equals 3 all over cosine theta. And then if I multiply both sides by cosine, I will get 3 equals r cosine theta. I want to get rid of all the r's and thetas, and I can automatically kind of do that now, because over here, x is telling me, that equation is telling me that right-hand side is just equal to x. And x equals 3 is familiar. It's the equation of a vertical line. We know that from working with parabolas with directrixes. Okay, so 1, 2, 3. And there is my perpendicular line. If you want to really impress me, you can note the orientation implied by this curve. So theta comma r, starting at 0, 3 secant of 0 is same as like cosine of 0 over 1, but so it's 1 over 1 is 1, and then try like pi over 4, right? So that would be 3 root 2, and so it seems to be going up. Okay? So it starts at 0, 1, and then it rotates over to angle pi over 4, at which point it's at 3 root 2. So it seems to be going up. Okay, but I wouldn't take off points. It's just show me the line x equals 3. And I'd probably be happy. Okay, I'm going to have you graph something as well. So you either need I'll either make it a circle or a rose curve or a snail. More than likely it'll be a rose curve though. So let's look at 77. R equals 4 cosine of 3 theta. Right, so what am I doing? I need to first get the amplitude. So you're either doing a table or you're graphing this thing in the r theta plane, or theta r plane rather. The amplitude is 4. Then you need the period. So you take the 3 theta and wedge it in between 2 pi and 0. Okay. Divide everything by 3. And then I like to get my tick marks. So I just divide that interval into 4 parts, same as multiplying by 1/4. So it would be pi over 6. And then I draw my little graph. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. By pi over 6's. Depending on how many I need, I'll go out to 12, 5, 6, 7, 8, 9, 10, 11, 12. And it's a cosine, so I'm starting at 4, diving down, and then diving back up. Okay, then I need to go over to my xy plane. Okay, officially this one was theta r plane. I go to my xy plane, I'm going to need 4 of these little circle thingamajigs. 2, 3, 4. And then I need some angle lines to guide my work. So I should be seeing work. If you just graph the thing, I'm going to say you used a calculator. And I'll be like, no, you get a 0. Okay, so you got to show me all your little details. And I want you to be able to do it by hand because of those integral problems. The calculator isn't going to be able to determine the beginning and start of something like a rose petal. Okay, the beginning and end of a rose petal. Okay, so anyways, these are pi over 6's. If you allow me to, 1 pi over 6, 2 pi over 6, 3, 5, 6, 7, 8, 9, 10, 11, 12 pi over 6. Okay. Okie dokie. And then we just start going, and I'll do it in red. So I start out at 4, and then it dies down to 0 at pi over 6. And then from pi over 6 to 2 pi over 6, it'll go negative, so it'll actually be over in this region. Okay, so it'll go like this, out to -4. And then from 2 pi over 6 to 3 pi over 6, it goes back to 0. So I'm still in this on the negative side of the arm, so it goes back to 0. And then from 3 pi over 6 to 4 pi over 6, it'll go back positive all the way up to 4. And then from 4 to 5, it's going back to 0. And then from 5 to 6, it's going to go, yeah, and then from, what the heck am I, this stupid phone. Somebody always got to call me. 5 to 6, it's going to go, so where is 5 to 6? 5 to 6 is like right here. And it's going to go negative up to -4 there. So you're actually on this side then, and it'll go like this. And then from 6 to 7, which will be this kind of region, 6 to 7, it'll go back to 0, but on the negative side. So you'll start repeating yourself. Okay, so it's just a 3-petaled flower. Yay. All right. Let's move on to integrating then. Okay. So in section section 10.5, number 10, find the area of 2 petals of a rose petal. Find area of 2 petals of r equals 4 sine 3 theta. So you got to graph it. I mean, there's no way to get around it, and you got to do it by hand because the calculator ain't going to tell you where one petal ends and one petal begins. Right, so first again, amplitude. So be, prepared to be able to graph a rose, a circle, or a snail. Okay, amplitude is 4, period. Wedging 3 theta in between 2 pi and 0. Divide by 3. So 2 pi over 3. And then get your tick marks. 2 pi over 3 divided by 4 is same as multiply by 1/4. So pi over 6. And then we can go to our 1, 2, 3, 4, pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5, 6, 7, 8, 9, 10, 11, 12 if we need it. And then it's a sine function, so this time it starts at 0 and does some oscillating behavior. Let me go over here to the XY plane. 2, 3, 4. Get some little diagonal lines. Oh, great. Circle 4. My pen is being nice enough to erase things for me that I don't want erased. Anyways, pi over 6, 2 pi over 6, just like the last one. 3 pi over 6, 4 pi over 6, 5 pi over 6. And if you want me to, 1 pi over 6, 2 pi over 6, 3, 4, 6, 7, 8, 9, 10, 11, 12 pi over 6. Okay. Okay, so again in red, from 0 to pi over 6 is going to increase to 4. So it goes out. Whoops, tried to do it in red. Okay. And then from pi over 6 to 2 pi over 6, pi over 6 to 2 pi over 6 is decreasing back to 0. And then from 2 pi over 6 to 3 pi over 6, it'll go to -4. So you're actually in that quadrant, or that sector, if you'd rather. Then from 3 pi over 6 to 4 pi over 6, it'll go back to 0. You're actually in this sector. And then 4 pi over 6 to 5 pi over 6, you're going back to 4 positive. So you go back into the positive sector. And then 5 pi over 6 to 6 pi over 6, you're going back to 0. And then from 6 to 7, you'll go negative and you'll end up in this quadrant, but you'll be retracing. So you're done. Okay. Okay. So basically, we want 2 petals. Because of symmetry, you can find the area of 1 petal and just multiply it by 2. Okay. So basically, we traced out, and I'll mark it out in blue here. We traced out this 1 petal going from 0 to 2 pi over 6. Okay, which is pi over 3. So I should be able to just go 1/2 integral 0 to pi over 3 of our 4 sine of 3 theta squared d theta, and then multiply that by 2 because I need twice that area. Okay, so I need 2 rose petals. That thing in the big square brackets will just give me the area of 1 rose petal, but I need 2, so multiply it by 2. Okay. 2 times 1/2 is 1, so I just have this integral, 16 sine squared 3 thetas. And then I'm going to have to use one of my trig formulas. I could factor out a 16, but I'll have 1 minus cosine of 6 theta over 2 d theta. I can factor out 1/2. I get 8. Integral of 1 minus cosine of 6 theta d theta. Then I'm going to integrate. So I have 8 times theta minus sine of 6 theta all over 6. And I'm going from 0 to pi over 3. Plugging in pi over 3 into the antiderivative, I get pi over 3 minus sine of 6 times pi over 3 is the same as sine of 2 pi. Sine of 2 pi is 0. Okay, so that will be 0 minus, plug in 0 into the antiderivative. So 0 for theta is 0, minus sine of 0. Sine of 0 is, again, 0. So all that stuff is 0. And you're just left with 8 pi over 3 for your area. Okay, so that's about it. This test will be worth less because there's not as much material. Okay, so this test will be worth 50 points, and I'll make it a written test, kind of getting away from that WebAssign stuff. I just have way too many issues with it, with students cheating and all that jazz. Okay, so that should be good enough for us, and we'll see you next time. Thank you for watching.